Okay, so now we are doing today's GFG daily problem. Okay, so date is 18/1/23. GFG daily problem of the day is find the first node in the loop of a linked list. Okay, so there is a linked list given to you, and this linked list can contain a loop, or if does not contain a loop, you have to return -1. If it contains a loop, then return the node data of the first node of the loop. What do you mean by the node data of the first node of the loop? Which means the starting point of the loop. Like this starting point is 3. Why? Because 3 is obviously going in this direction also, 3, 2, 4, 5, and again coming back to 3. So this is the starting node of loop. In this case, there is no loop. You return -1. So this is a standard loop detection quotient in a linked list. Yeah, and that's what it is. And you have to return the data of the that node. So let's do it like that also. So currently, the code I'm showing you in this, like I'm starting for the. Okay, let me just do this. So reset code. Okay. So currently, what how we do cycle detection in a linked list. Okay. So this is the logic of the cycle detection. You make your start node is equal to head. Okay. So there is a logic for slow and fast pointer, right? Slow and fast pointer. What does it mean? That you move your slow pointer by 1 unit, moves by 1 unit, and your fast moves by 2 unit, right? So fast moves by 2 unit, and then if slow and fast meets and fast meet, you say there is a loop, else no. So basically unit. So this is the thing. Like there is you can call it slow and fast pointer technique, or some call it tortoise and hare technique. I don't know, hare and tortoise method. So basically, this slow pointer is moving just 1 unit at a time. Fast pointer it is moving 2 units. For example, this slow pointer in this case, if I talk about, so one. Okay, yeah. So your slow will move to 3 in 1 unit, and your fast will move to 1, 2, 1, 3, 2. So fast is over here. And then your slow will move again from 3 to 2. In this case, like fast will move from 2 to 4 to 5, and fast is now on 5. Slow is on, I think, 2. Now slow will move to 4, fast will move to 5 to 3 to 2. And when slow will move to 5, fast will also move to 5. Now slow and fast are equal. So basically, there is a proof for that. If you move the two pointers like this, one by 1 unit and two by is 2 unit, so other one is running fast, so there would be any, if there is a loop, so they will obviously catch up somewhere, right? Because they will keep on moving, and at some point they will catch up. Okay, so there is a proof also, like how much time they will catch up, that is also there. So they will catch up at this point, let's say 5. Okay, now after that, what you need to do, you need to see, okay, if they slow n is equal to fast pointer, which means the moving 1 unit and 2 units. If they meet, it means there is a cycle in a loop, right? So this is the logic, and you can say that, yeah, there is a cycle in a loop. Acha, otherwise you can also do this by other methods also. Like you can create a set for all the node data, and if the one value is repeating, that's why you can say, okay, and the node which is repeating first, so in this case 3 will repeat first, so you'll return the 3. So that is also what you can do. But yeah, we are discussing about slow and fast pointer. So now slow and fast meets at 5. We say ki, okay, that 5 is basically, how is it possible that if I move two pointers and they both are at same point, if I move with a different speed? So it means that there is a problem, like there is a that there is a loop in a linked list. Okay, that's why it is happening. So now you get that there is a loop, and what is the starting point of a loop? How will you get that? So there is a logic for doing that also. So currently what I'm going to show you is, step one. Step one is finding detect a loop. Step two, if loop, then uh, then find the start point. If not, then you can else return -1, right? If there is not loop, you can just return -1. Okay. So now let's start detecting the loop. So for detecting a loop, I just told you, like slow pointer is equal to will start from head. Your fast will also start from head. It's not like, yeah, you can start from it head or next also, but yeah, the like now you will move while Now your s is s ka next, not s ka next, basically f ka next exist and f next ka next exist. Okay, there is a one method like this. You'll move your slow, you'll move your fast. Okay, so this is the not like this. You move a do while loop. Okay, you can also do it using a do while loop while your s is not equal to fast. So currently slow is equal to fast, but what does this do while loop means? Do while loop means this will at least run one time. So when it will run one time, I'll change this slow to slow dot next, and I'll change my fast to equal to fast dot next. Now there is a guarantee that these two are obviously not equal, so it will keep on happening until so on. Otherwise, you'll get a point when slow is equal to fast, then you will say okay, there is a list. But there might be case when your fast can become null, right? When your fast is null or fast is next is equal to null. Okay, where there is fast is null or fast the next is not is null, you will say return -1 in that case, right? Otherwise it will break out at point where s is equal to f. Now what you have to do while your s is not equal to f, okay, now you will change your s to head pointer again, right? So this is the logic, this is the first part done. Detecting a loop is just these three lines. Okay, if do while loop, and when your while your start is not equal to your slow is not equal to fast, move start by 1 unit, f by 2 units. If they catch up, then you will say okay, there is a loop. If there is if they don't catch up, which means in you will find a null at some point, right? Because the linked list is ending, and in this case, so either your because fast is moving so fast, so he will catch the null first. Okay, he will move to the end first. So if the so there is no need of checking whether s becomes null or not, because yeah, you can do that, but that's irrelevant, because if your fast is null, your you can say like yeah, it's you return -1. Otherwise it will take some time to slow to also reach null point, right? Because fast is moving fast, so it reached the null fast, so that's why return -1. Now you said okay, I got the if I say like there is no loop, you will return -1. If I'm going after this, it means there is a loop. So for detecting a loop, there is a logic that you keep your fast pointer where it was. Like it was found at 5, slow and fast meet at 5. Keep your one of the pointers at 5, or you can take slow, or you can keep fast at 5, and move your different pointer, another pointer, to the starting of the list, right, head of the list. And then now iterate on the both, like, but how? Let's see. S will also iterate by 1 unit. Okay, it will move by 1 unit, and f is also moving by 1 unit. So this is the logic. F is equal to f dot next. Slow will also move by 1 unit, and fast will also move by 1 unit. There's a mathematical proof for this. When you do this, and when you catch up your slow and fast at one point, and then if you move your slow by 1 unit as well as your fast by 1 unit after placing your slow at head, obviously, then they will meet at a certainly that point where there is a starting point of a linked list. In this case, you will go your slow to head. Slow is now pointing at 1, f is pointing at 5. Move slow by 1 unit, it will reach 3. Move f by 1 unit, it will reach 3, and that's why that's your answer. So yeah, so now you can return s dot data, and that's all about this. Let's try to sum this up. Let's just comment this up. Detecting a loop, successfully submitted. Now I want to do the another approach also, in which you do just one pass only. Okay, this is just detecting a loop. Okay, and this is just finding the starting point, finding the start of loop. So we can do this in one loop itself, but for that matter, you have to do not while, but while of, not do while, but just while your same condition f and f dot next exist. Otherwise, if it doesn't exist, you will return -1. Like over here, you will return remove this while loop from here. So now the first thing is same. S will move by 1 unit, F will move by 2 units, and then there comes a point if S becomes equal to F, right? That was coming a point there. I was breaking that loop. Now I can just proceed in this loop only, and I can run a if loop for that, right? If yeah, I can run a just if statement for that. If S is equal to F, then do this. S is equal to this head, and then while these two becomes not equal, these two are not equal, move both of them by 1 unit, and at last you will return s dot data. Otherwise, if that doesn't happen, you return -1, and take this out and take this out, and just let us try this. -1 where expected what? 89. Okay, while I think I just not put the curly brackets on. This is okay, fine. Now this is fine, I think. While your fast and f dot next is not null, if it becomes null, it means there is not loop. Return -1. Otherwise, just move your s pointer, f pointer if they both become equal, which means there is a loop. There is a loop. Is a loop. So just find the point where the loop begins and then just submit this up. The basic things are same. In case of 5, he's saying -1 loop exists at the data is 3, while your s is not equal to f. F dot next, if s is equal to f. Question f dot next exists. Just go to that and what's the issue in this? Okay, I think instead of just having this, you keep another iterator also, it, or just name it I, while your s is not equal to I, s is equal to s dot next, I is equal to I dot next, return next data. Okay, which case it was not working? I think it was the first one only, right? So 1, 2, 3, 4, 5, and there was pointing at 2, I think. 5, 2, 3, 4, 5, and 2, I think. Yeah, that was the case, if I'm not wrong. Mm. It's returning -1. I think you have to do while f next is not null and f next is not null. Like instead of that, I is equal to I dot next. There's no problem in that. While f dot next is not null. Okay, but there is no null in this. How it's returning -1? Yeah. Okay, let me see about this. Okay, so there was a silly mistake which we were doing. It's this f and f dot next exist, right? So you have to write it like that. I was writing while f is not null and f dot net is next is null, so that's not possible. So yeah, the main logic is same. This while condition has changed. What is this issue? Okay, so instead of I now we can just use our s and f pointer because that should not be an issue. right? S is equal to head, and while S is not equal to your fast, move your fast and move your slow, return S dot data. Okay, I think it's submitted. Okay, guys, so that's about it. Pretty standard question if you know cycle detection using the two pointers, slow and fast pointers, right? So that's the logic for the slow and fast pointer. You don't need to go inside the proof, exact proof of that, but you should know that if I'm moving a pointer by 1 unit at a time and another pointer by 2 units at a time, they should not meet in any case if the linked list is just straight and does not have a loop, because slow is moving very slow and fast is moving really really fast, so they should not catch up at some point. But if they are catching up at some point, that definitely means there is a cycle, there is a loop, because fast is moving really fast. So maybe like slow has covered just three distance, fast has covered six distance obviously, and there is a loop of 3 units. So basically, yeah, they are at same point. And then you say, okay, if they are at same point, there means there is a loop 100% for sure, because otherwise slow is very fast and fast is very fast, or you will surely catch up the null at some point, right? So that's why you can just return -1. And otherwise, if they both become equal, there is a logic for how you are getting to the first point, right? How for the starting point of a loop is just make one of the pointer to the head, and then move just each of them by 1 unit. Okay, so you can make either S or F equal to head, and then just iterate over them and return S dot data when they both become equal once again. Okay, guys, that's about it. Bye.